Hi guys, welcome back to the shop. Today I'm going to get on a boring job on a 125 Suzuki Duster TS125. I'm trying to finish up some of the stuff I've had laying around here for a while, and this one here looks like it's going to be a pretty simple job. Doesn't have a lot of wear. It's had a piston stuck in it. So we're going to go ahead and go to the next size. It's standard bore now. We're going to go to 1/2 millimeter over 20 thousandths. So let me get you overhead and we'll take a look at it, and then we'll set it up and we'll start boring it. Okay, let's take a look at it. I think you can see the aluminum stuck to the cylinder over here, and a little bit on this side also. So it mostly here on the exhaust side. Everything over on the intake looks pretty good. Hopefully you can see that. Okay, this, like I said, is a standard bore, and on this particular model here, we want to measure at 0.35 thousandths above the exhaust port. It's kind of hard to measure. I can't get anything in there to kind of do it, so I'm actually a little bit high with the little mark I put right here with a blue magic marker. So it's just below it, and when we check on the piston, it's telling me to check it at 0.90, and that comes out to right about here. And these are all thousandths I'm talking about now. So right 0.90, just below the lubrication hole there. I haven't seen a piston like this with the hole, but I'm sure that's what it is. Most of the ones that I've dealt with were older, and probably old stock, and they didn't have the hole. But I believe the reason for it is, let me see here, see, that's on the intake side. See, here's the exhaust side over here with the arrow, and it's over here on the intake side. So I believe that the idea is to run along this web between the two pieces of the intake port and give it a little more lubrication under there from whatever flows in under here and then squirts out. That's what I believe it's for. So to measure this thing up, we know what we're going to do. We just want to see if we can get a good measurement to see where we're at. And I've got my snap gauge in there, and I'm just going to get it locked at kind of an angle. I pull it out, and we'll give it a measure. Okay, we're right at 2.207 right now. Let's see here on the manual. 2.205 is standard bore. 56 millimeter. So we're a little bigger than that, and that's because of the clearance that was put in for the clearance between the bore and the cylinder. So at that point, you know, if this problem hadn't have stuck this to the cylinder, I think it was probably a pretty good bore. You know, I'm not going to go through and check all the taper and everything, but you know, it probably would have been okay. You know, if you really wanted to spend some time and try to save it, you could use a little caustic soda or something and try to dissolve the aluminum in there, but you've got to make sure that you don't get any out here. So that's the problem. You've got to be very careful with that kind of stuff. Or you could try to hone it, but I think, you know, if you're basically at 2 now, and you know, if you hone this, then you're going to be out into it a little bit more, maybe even a thousandths to get that off there. So going to the next size is the right thing to do, and we'll just set it up. Let's see, the clearance is 2.0024 to 0.0028. So 2.5 thousandths is what they wanted. So that's what we'll give it. So we've got all this set up into the bore gauge, and let me see if I can get you out here just a little bit so you can see all that. And again, I'm going to try to measure this right here at the right spot. And I've got 1 revolution built into this thing. So there's 1, otherwise 10 thousandths. So about 16 thousandths. Okay. What I put into here is the diameter of the piston. I'm sorry, I should have measured that first. But again, we're measuring right at the hole here. Like I say, I should have got that measured first so it'd make more sense what I'm talking about. And yeah, 2.223. So we were at 2.207 on the cylinder, so 16 thousandths. That's just what we measured here. So we're good to go. We know that we need to be we know that we need a 0.5 millimeter over piston. We've got that, and that the cylinder is at the standard size at this moment. But there's a lot of caked on. Let's see here if we can get you down there a little more. A lot of caked on aluminum there. But most of that will come out in the first pass. Okay, so let's get started setting it up. This will be the first the first boring job in the new mill. Okay, I've kind of got all my equipment setting over here. First thing we want to do is just make sure that you don't have any gasket material and everything is in good shape here on your base, because that's where I'm going to mount everything. Everything's good there, and doesn't really matter how you set this up, but I like to have the exhaust port to look up into, so that's what I do. So I'll go ahead and start getting this fastened down, and then we'll get to it. And I'm using a little piece of aluminum here on the top of the cylinder so I don't bugger it up. And we'll just get this kind of situated so we can get her clamp fastened down here. I think I keep getting that kind of rough nut there. All right. Okay, you can see here that we've got the 1, 2, 3 blocks positioned underneath where the gasket goes, and you want to make sure that you've got it far enough away. Remember, your cutter is going to come out of the cylinder slightly right here where this is cut out on the side. So make sure you've got it far enough away so it's, you know, we've got more than enough room set up here, but it's just something you need to watch. Another thing on these is the cylinder sleeve right here is actually higher than this portion out here. So you don't want to be up on top of that because you're not going to have full contact with your clamp here. So another thing just to kind of watch when you're setting one of these up. And then we just want to make sure we get it secure. Then we just want to take a quick look here and make sure that we're in the teeth here on our support, and make sure that everything is square and solid, and so it's not rocking or something that might move when you start doing the bore. So looks like everything is in pretty good shape. Okay, as you can see here, the spindle is not exactly in line with the bore, so that's what we're going to start working on now. And we're going to use a coaxial indicator to get us started. Okay, the next thing we want to do is we want to put a 3/8 collet in, and that's to mount our coaxial indicator. It's got a 3/8 stud, so that's going to go into that. You got to hold on to it while you're getting everything tightened. I know you can't see what I'm doing at the top here, but got to draw a bolt, and that's up here, and I'm tightening that up, and that'll hold the indicator in. Now at this point, we'll go ahead and stick the appropriate feeler in there. It's got a little flat spot on one side and a set screw on the other, and we'll just give that a little and lose my wrench. Okay, and then we'll just hold this out and go ahead and raise it up. I don't think you can see anything there. Just hold it out, and then we'll raise it up just to get it into the bore, just right at the top. That's the non-worn area, just above the piston rings. Okay, so then that's where we're going to start our checking. And I've got to get an arm on here so I can hold this thing. It moves around unless you put an arm on it to hold it, and that's what we're going to do right now. Okay. So I know it's off quite a bit. I just like to get it a little kind of close before I turn the machine on. So let me get to that first. Okay, I've got it pretty close here, so we're, like I say, we're just above where the rings go, so that should be the, at least in the top, that's the least worn area usually. So I'm going to go ahead and fire it up, and I just kind of eyeballed the two axes, and we'll see how close I am here. Okay, not bad. So I'm just going to work. I'll start with the Y. See, that's a little better. Now I'll go over to the X. That's worse. That's getting better. And I did trim all this in before I started. Spent quite a bit of time with it last night doing that. Making sure everything's straight with the spindle. Oh yeah. There you go. Right on the money. We'll go ahead and check it with a test indicator and make sure though. At this point, I don't know if you can see that or not, we'll zero out the DRO, and we'll do it again when we check it with the test indicator. Okay, we've got our test indicator in here, and I'm actually going to zero it out on the back side so I can see what the difference is here a lot much easier. So let me move it around there. You can see that it's off about 1/1000. So let's see if I turn it the right way here. Gotta get this out of my way. Okay, about 0. And we'll move it up to the front. And we're about 1/2,000 maybe. Let's see if we can. Oops, wrong way. Okay, now you only do one axis at a time. You'll drive yourself crazy. Okay, I think you can see that we're just about 0 back there. And move it back up front, and we're still 0. It's okay, start on our X. Okay, we're at about, let me just 0 it there. And now we'll go over to the other side. And you can't see it. You still can't see very good, but it's about almost 1/1000 off. So I'll move it about halfway. Take it back to the other side. 0 it out. And then come back to this side. And that's good. Now let's make sure that our Y-axis hadn't changed. See, it has a little bit. And almost. Okay, that should be 0. Zero. 0. Yep. 0. and just about a half thousandths. Let's see if we can pick some of that up. It's about halfway. Move it back there. You can see this takes a little time. Okay, so we're at about 0 there. We'll move around here. Still on 0. Move to the back. Just a little off, about a half thousand. So I'm going to keep working on that one. And we're 0 over here. So let me work on my, well, maybe if I zero that one out. Let's see where we're at back there. Yeah. I've got a little egg shape, I think, in the cylinder. So I think I'm going to go with that. It's close enough, within a half. All right. We're as close as we're going to get, I think. 0. 0. 0. And 0. So I'll go ahead and pull this, and this time we'll reset. Z really doesn't matter. And I'm going to lock my my locks on the table and the slide. Okay, now time to get the boring head in. Okay. Just above the top there, and then we'll run it down. Just to the where it clears the cylinder and the bottom. Right there. So there we can reset our quill to 0 here. So we know when we get down to 0, and anywhere in between there we'll kind of know where we're at anyway. Okay, at this point I've got just starting to get a drag on my tool bit. So I'm just going to lock it in right there. Slightly. A little bit heavy on the exhaust side, looks like. We'll run it through once and see what it looks like. And if we need to make adjustments, we can do that. Okay, taking our first kind of easy pass through there. And just see what we end up with. It's hitting a little more on the front, but the cylinder is centered. There's no doubt about that. This is just a pass to see what it's looking like, and if we need to make some adjustments, then we'll do it. But generally, this is going to happen, and you're, because when it was bored the first time, it may have not been completely centered. So it's just something we have to deal with. And I think you can tell already that it's gone out of that. It's not cutting anything right now that I can see. So we'll just let it run through, and that'll give us a picture of what the cylinder looks like. So I think you can see right now that it's cutting the aluminum out. It's just barely getting it, and it's cutting the aluminum off of the cylinder surface on this first pass through. So that's all you're hearing it cut right now. And as soon as it stops cutting, then I can set my automatic shut off. I think we're there, right there. I'm going to zero out my quill and then adjust my shut off to right there. Okay, so that should be good. So we'll raise up our quill and see what we've been doing. Yeah, everything looks good. Pretty patchy right now. I think you can see right here where it's cut a little bit, and there's a little bit on the other side in the same area. So we'll just adjust it and take the next pass. And we actually, let me see if I can get you around there to see that one. You can see here where it just cut on this front area, the exhaust side, just where the okay, our second pass through here, and looks like cutting just about all the way around. A little bit spot over here that's not cleaning up. So I think we're just going to leave it where it is. Looks like that's going to be good, and we know at least this way the cylinder's centered. We took 2 more thousandths coming out this trip through. This last cut, the cut that we're doing right now, has removed 12 thousandths. No, I'm sorry, 6 thousandths out of the cylinder. And it looks like it's just about going to clean it up, except for around the exhaust port. So I'm real happy with that. Seems like it's a very little worn cylinder. It's just too bad it stuck the piston. You can see the bit coming out. Yeah, maybe you can't. Yeah, it's not real visible, but it's actually coming out from around the where the transfers go. So we're almost to the bottom right now. It'll shut off by itself here in just a little bit. About 70 thousandths to go. The hand there, right there, the handle released. Okay, let's take a look at it. You can see there, I think, that we've got a little bit left around the intake ports to clean up yet. And let's see, get you back here. And right around the exhaust ports. So that's just the normal wear pattern. So if you're getting this, it's wearing properly, because you're always going to get wash around the exhaust and the intake, and a lesser degree on the transfers. But I'm real happy with that. That's 6 thousandths removed, maybe 7. You know, it's kind of iffy on the first one. So at this point, we'll take a little sandpaper here and hit that. I don't think it'll go yet, but it might start. No. We've got probably the next pass, it'll start. So I like to go until I'm just about to the top of the pin here. So then I start honing. So it's a real nice even wear from what I can see. All of the piston goo has been removed, and it's looking real good. So we'll take another 2. And let's see if I can dial in another 2 thousandths. Right there. All right about there. Just check our insert over good. Looks good still. I'm running about 150 RPM. That's a little bit faster than it was on my old machine. We got race motorcycles flying by the house here. Big bad 4-stroke. Well, there's a 2-stroke with him too. That 100cc 2-stroke's probably outrunning that 450 4-stroke. I'm sure liking the new machine. It's a lot quieter and it just holds its accuracy so much better. The other one was just wore out. I mean, it bored cylinder's okay, but it was harder to set up than this one just because it was so loose. Bird's eye view up the exhaust port. Never know what lighting is the best. You can see the insert now in the exhaust port, just starting to get in there. think we're probably getting pretty close here. Yeah, perfect. Just what I like, just to the top of the pinhole here. You can see it. That gives us just enough to hone out and to fit it perfect. And you know, we'll take it over the bench, we'll measure it up, see where we're at. Let me shut off my rotary phase converter. Makes it a little quieter. Except I got the guy next door mowing his grass. It's always something. Okay, got us a nice little pile of cast iron down here. All right, let's take a look at what we got here. Cleaned up real nice. So there we go. Okay, let's see if we can try it again here. It's kind of hard to get the cylinder and the gauge in there. It's long. See, we're about 3.5 thousandths here on the minus side. So that's, like I said, we're about 3.5 thousandths before we're the same size as the piston on 0. And then we put our clearance in, be on the plus side. So between 2 and 2.5 thousandths. It drops right down there every time. So that's where we're at. And that's usually where I stop. It's you know, you could board another thousandths or two and be okay, but I just like to be cautious, and that way, you know, it doesn't take very long, you know, 15 minutes, and I'll have it down to where I need it to be. So it's doesn't take that long to hone it. So there we go. We've got another cylinder bored, and we'll be getting to the honing and the piston fitting pretty quick. So there you have it, guys. Another cylinder saved, and this one's got life left in it, so it can go another, it can go up to 1 millimeter over yet, but I think this will last him a good long while, and won't have any trouble with it at all. So we'll get on the honing and the piston fitting, along with the chamfering the ports, and I think I've got a cylinder head for it I need to check the flatness on, and I'll also check the flatness on the cylinder before we send it all back. So hey, thanks for going along on the ride, and we'll see you next video.